So let's start. Let's introduce myself. So I'm Clement Escoffier. I'm core developer in the Vert.x team, and I'm going to present in around 1 hour, a bit less, a new project we have started a couple of weeks ago, in Vert.x, which is a microservice toolbox. Well, you probably heard a lot of things about microservices, and that is so cool and so great, the relationship with monoliths and so on. So we will try to demystify everything and tell you the truth about microservice, because microservices are not new. They were invented 30 years ago, probably a little bit more, and most of the things we are doing around microservices comes from the 60s, so nothing is new. We just refurbished a bit all the patterns we did, and let's have a look at this. So this presentation will be a couple of slides just to explain a bit what we did, and then a lot of code. So don't worry, if you want to see code, you are going to see code. But no fancy UI. I'm not a web developer, so it's going to be just pure text. So already said that. So there is no real definition about what microservices are. There is these definitions that come from Martin Fowler, that is 1 year old, 2 years old, which says that microservices are an architectural style. And the main idea of this definition is to say that a single application will be decomposed in a suite of small services, each running in their own process and communicating with a lightweight mechanism. All those services are developed independently and deployed independently with a fully automated deployment system. And there is some central management which is reduced to the smallest thing as possible, and we will see that the smallest thing as possible is not really small, but you need to have something. There is no magic. You also say that services can be developed in different languages and different frameworks and so on, and that's one thing that is really relevant with microservices. Is even if this screencast is about Vert.x, you can implement your services in any technology you like. Even Java EE is perfectly suited to build microservices. So there is other definitions of microservices. That one, even if there is no consensus, that one is the one that is the most used today. The main part is a suite of independent small services. So the first thing here is a small. Microservices is, at least in my opinion, not the right word, as the size doesn't really matter. What is a service is just what you define as a feature that can be isolated and developed independently from the rest of your application. It can be big, it can be small, it can be a teeny service, it can have one method or 20 methods. We don't care. It's not really about that. What is important is that each service runs in its own process. That means that it will live completely separated from the other services, so it can die without the other services being aware of this or being replaced. From the definition, the interaction needs to be lightweight or use a lightweight mechanism. What is cool is lightweight doesn't really mean anything. It's really fuzzy. And something that is really misleading, and a lot of people have understood lightweight as, oh, it's REST. So no, there is nothing in this definition and none in any other microservice definitions that enforce the REST interaction style or architectural style. It can be REST, it can be message-based, it can be events, it can be streams, it can be file-based, it can be a pipe, it can be anything, RPC, anything. There is also nothing in this definition about the coupling between the services. It can be strong coupling, loose coupling. So it's really up to you, and we will see in the next slide why loose coupling is recommended. There is also nothing about synchronous or asynchronous communication, even if we mostly agree, everyone mostly agrees that microservices are distributed. So as they are distributed, there at some point there is some network interaction, and most of the network interaction at some level are asynchronous. So again, what's one of the major features of microservices today is that they are independently developed, still deployed, and the deployment should be almost automated. One thing that is important too is that they are substitutable. So if I have my D service that was in V1 and I want to deploy a V2, as soon as this V2 exposes the same service, so the same interface to the world, same event, same REST API or whatever, it can be replaced. It can replace the V1, and this should be almost automatic. So it's a Liskov substitution principle that we used a couple of years ago in object orientation. Then we used it in componentization, and now we use it with microservices. So if you look at the roots of Liskov's principle, it's very, very old. So again, nothing new, very old techniques. So microservices, as we say, are most of the time distributed. And sorry, guys, but there is no free lunch. And distributed applications are hard. Distributed systems are complicated, and they will fail. We all know that a distributed application is going to fail at some point, generally in production. So the first things you will have to do when you develop microservices is some discovery mechanism. A microservice alone doesn't really have much value. It has value because it can rely on other microservices and can be used by other microservices. So first thing you have to do is some discovery. Where is D? Where is B? So if I take the context of A, and for this you will need to have some infrastructure that will store the available services and let you find them. The second issue in a distributed application is how to keep everything on track and everyone on the same line. So how to be sure that everything is working and that everything is compatible with the rest of the world and so on. So we will need monitoring, health, distributed tracing, and so on. Obviously, as I say, distributed applications fail, and they all fail. So there is nothing that will prevent you from a failure because they are complicated, and there is physical law of physics that may decide that your hard drive just is going to die, or that the network is going to disrupt, or the connectivity is down, or whatever, or your database is full, or there is many, many reasons for a distributed system to fail. So instead of trying to build a bulletproof system that will never fail, you should, at least one way, and probably the preferable way, is to say, okay, I know it's going to fail, and I will develop my system to handle those failures. So when doing a microservice system, you will have to think about how you are going to isolate those failures or to react to them. And don't forget that you have a user, for example, someone that is going to your website that is waiting for an answer, and they don't want to wait forever. So you need to react smoothly, but fast enough to keep the user happy. Failures are not only fail stop, like a crash, but you will have, and you will probably already see that, you have Byzantine failures, which are the other type of failures we can imagine, which, well, it's a failure, but to detect it, you will need to know what will be the expected answer for each request. So it's the worst kind of failures, but it's also happened. So no magic, no free lunch. When you think about a microservice, it's not a REST API that you will do on your machine using any framework. It's more than this. You need to think about discovery. You need to think about fault tolerance. You need to think about monitoring. This includes logging, tracing, metrics, and so on. You need to think about scalability. It's good to have one service, but How does it scale? How do you balance load among instances and so on? As said in the definition, you need to think about the deployment and the automated deployment of this. Of course, you will need to think about security, authentication, and so on. Or you will manage several versions of your service at the same time, or you will redirect user from one version to another one, and so on. Actually, if we look at this more carefully, this is exactly the same set of concerns you will have if you do a distributed application. So again, there is nothing new. We always had this to manage. We just didn't call that microservice. So microservices is just a set of techniques that will let you build such kind of system. But it's far from being easy, and that's why we have built this Vert.x Toolbox. Often, microservices are compared to monoliths, and a lot of talks and articles and presentation are about taking your monolith and trying to split it inside pieces that you call microservices. But again, there is nothing really inside the definition or inside the practice and the tools around microservices that avoid you to create a new application using the same concepts from the microservices concepts. So that will let you isolate your technology choice. You like Spring Boot? Let's do your REST API using Spring Boot. You need some reactive elasticity and scalable parts in your application. Let's use Vert.x for this. Anyway, it will communicate somewhere or some other way. It will also let you build multiple parallel iterations if you are in a large team. So you divide your team in a set of clusters, set of people that will manage one service or a set of services. And they will be able to iterate like that. So the whole iteration of your system will be the combination of all the smaller iterations. So microservices are not necessarily about cutting a monolith in pieces or reducing its size. It's really about increasing the agility and reducing the time to production. Time to production, which is different from time to market. Time to production is the time between you start your development and you reach the production environment and is used by your user or the rest of your ecosystem. The good news is Vert.x is already really good at this, at reducing the time to production and has a very small, very efficient time to production. So today we see a lot of Vert.x application in production, and the path to production is very, very short and very fast. Is it new? Again, no, it's not. I will cite a couple of cool technology you all love. Let's start with Corba. Well, Corba was implementing some kind of microservices that was late 90s, beginning of the 2000s. Genie2, OSGI. So OSGI is not distributed, at least the core specification is not distributed, even if there is some other specification to about distributed services with OSGI. OSGI are kind of microservices too. Web services and all the SOS stuff. If you ignore the ESB trend, which was really made for integrating systems, but if you take pure web services, so SOAP and some kind of discovery, even if UDDI was not heavily used, this was very close to what microservices are today. And if we look at the roots, there is this academic paper from February in 1977 about capability-based addressing, which actually is a pointer redirection inside an operating system with some discovery mechanism. And if you look at this, you think, well, it's very close to what microservices are today, except that it was in the 70s. I took this picture from a paper I wrote in 2007 about almost the same things that microservices are promoting today. In microservice, we have a couple of entities. We will have consumers that will use services. We will have providers that will provide services, and we will have some host, some kind of discovery mechanism that will let the consumer find the right services and the provider to publish, remove, and update the services they expose. So again, nothing new. You can find such kind of schema in a lot of places in the 70s, 80s, 90s, and 2000s. Okay, so let's start with the toolbox now, the why, what, and how. So the first thing is that Vert.x was made to build microservices from its early age, and that's something very important. It was designed to be able to develop microservices systems before microservices become the trend, and even the microservices word was coined. And actually, it's all reused concepts that are pretty old. So what do we have with Vert.x today? All Vert.x components will run in independent processes. It can be fragile, it can be launched with a Vert.x CLI or whatever. It will be independent processes. It will support multiple communication channels. It can be HTTP, so we have a built-in HTTP server and client, the event bus, TCP, and so on. We have monitoring with the metric SPI and two major implementations, that is the two from the official stack, one about using Rock Wizard, and another one using Rocular. And I think there is a couple of other implementations made by the community. But what is missing to meet this definition of microservices, so the definition I used at the beginning, is independent and automatic deployment, AB, blue, green, and so on. Discovery mechanism beyond the nodes, so Vert.x lets you build distributed applications that the cluster is automatically made, but all each node expose the feature exposed to the other nodes. This is not supported, at least by Vert.x Core. How do we isolate failures and how do we react to that? Vert.x Vert.x is mostly asynchronous and is using asynchronous results for most of its interaction. The notion of failures is there, and you will be able to handle failures. So that's given. But sometimes you want to go a bit further than this, and we will see how we can do that with the toolbox. Health checks. So how can you be sure that everything is there and reply and alive? How to do tracing, logging, and so on. So as far as today, not all these features are provided by the toolbox. It's more where I intended to go. Today we have a discovery mechanism and we have the failure isolation, and we are starting working on automatic deployment and stuff and health check. Well, I have experiments among all of them, but what's inside the toolbox right now is the discovery and the failure isolation with the circuit breaker. So this discovery service, don't worry, we will switch to code soon. The discovery service, again, it will let you find the service you want regardless of the environment. You can be in dev mode, you can be in prod, you can be in QA. You will look inside the discovery service and it will get you the one that is available at that time. So obviously you can use DNS for that, but DNS will only work if you have some DNS things, so HTTP or something like that. And if you are in dev mode, except if you really want to set up a DNS server on your machine, it's not something really convenient. So here we go a bit beyond that, a bit further. So it will let you expose REST API, service proxies, data sources, services that are not developed with Vert.x. So anything. Discovery is the first step to adaptability, and we will see that later. So how is it structured? So actually, discovery service, how it's made, is very simple. It's a storage of service records, which is a structure, such as JSON, that will define what kind of service it is, where it is located, some metadata, and so on, and a name, and so on. So the discovery service will also provide an API to create and publish records, and so that's for the provider and for the consumer, an API to retrieve the service records, to filter them, and to get the service, the actual service you really want to use. It will support different types of services, so it's not REST only, it will be anything. And it supports bridges with other discovery mechanisms such as Consul, DNS, Docker, Kubernetes, and so on. You can change the storage backend if you want. By default, it uses a distributed map. And you can implement some dynamic scenarios with the service notification too. Again, so service type, it's not only REST. Right now, there is 3 types which are currently supported, HTTP endpoint, event-based services, so service proxies, and message sources. What is important is that for each of these service types, when you retrieve the service, it will be a different type. For HTTP endpoint, you will get an HTTP client already configured. You just have to use it. For event-based services, you will get a service proxy. And for message source, you get a message consumer. You just have to attach a handler on it, and you're good to go to receive the events. Let's see that directly in the code. Let's see that in the code too. And this will be for later. So let's do some code. Is it running? Yes. So I will publish this code on GitHub after this hangout. It's basically a set of examples. I have started this discovery vertical, which will provide QUI, this one, and something that is probably called circuits. Yes. But there is nothing here, no services and no discovery. So that's just some UI. So we asked me to increase the font size. Okay, so the first thing we will see is how to, you have a REST API that you developed with Vert.x and you want to expose it so a consumer can use it. This is a very simple REST API where we just have foo/foo and do foo, just say hello. So very simple. But then you need to publish it. To make things a bit more complicated, when we will start the HTTP server, we will use the port 0. So we don't know in advance the port that will be used. So here you will see that, well, you have some way to discover this port on the consumer side. So then you create a discovery service. So the discovery service is created like that, discovery service.create Vert.x. Every consumer and provider will have its own discovery service instance. And then here we are on the publisher side. So I will create a record. And for this, as it's an HTTP endpoint, I just create record. That's a name here. And that's some details about my location. So I will be exposed on localhost on this port. So port is actual port. And my root path is that one. And then you call discovery publish with a record, and you will get a notification to know if it has been done correctly or not. So if I start this, and if the network is working correctly, I hope so. Okay. And now I go there, refresh. See, the service has been exposed. So how it works, the discovery services are, we increase the size of this. The discovery services have taken this record and publish it on a distributed map. So every member of the cluster have access to all the services that are being exposed. There is also a REST endpoint to consume, to find the services, to publish services if you are not on the cluster. So here, what do we have? We have the name. Okay, that's just a name. The status. So right now, a service can have 3 status: up, everything fine; down, well, you're not there anymore; and out of service. That's a registration ID that will be used to modify the service or to unregister it later. And that's the location metadata. And here you can have additional metadata too. When you're done, when we call stop, you need to unpublish the service. So for this, you do discovery.unpublish, the registration, and that's all. Okay. On the consumer side, it's mostly the same. you get the discovery service, you create it, and then you do HTTP endpoint.get, and here's a Vert.x, a discovery, a filter. I will come back to that in a couple of seconds. And here you have an async result that will return automatically an HTTP client, because here we know that it's an HTTP endpoint. There is a low-level API that is actually what this one is calling, where you will manage the records, and from the records get the service reference, and from the service reference get the service object. That's exactly what is hidden behind this. Here, there is a filter here. So filters are expressed using JSON object for now. So I'm thinking about using function for that, but when I designed it, initially functions were not supported by Vert.x. So so I will answer to Julien right now. So it's just being why it is called HTTP endpoint.get and not get client. It's because it's the same interface for everyone. So we will see if you want to use a service proxy, it will be also get. That's, we could have a second method, but you should have a common interface. So again, about the filter here, well, it will just be it's just a JSON object where every field will match the value you gave. There is a special value with star, but basically here it will look for a service where name is full REST service. You can use any metadata that you have here. So you can use the name, you can filter on the status, on the registration ID, but that's, I don't see the point here, on the location or on the metadata. So you can filter on anything. When you get it, so then you can just invoke directly the service. So if I do that, oh yeah, it will consume the service. As I said, this is just some syntactic sugar to get the HTTP client. If you want to see the real code that is called behind the hood, it will be that one. First, get a record with the same filter. If you have a record, get a service reference. And once you have the service reference, get the actual service object. So if I launch this, I should have hello. So what the service is exposing here. So this hello twice. Once from this call and the other one from this call. Let's launch that. Again, I have no clue on which port it is deployed, and the consumer has nothing except a name here. So it doesn't know the host, it doesn't know the port or anything. Here we have the two hello here, so maybe I should increase here. So hello, hello, so it has worked. If you want to see the port is was that one. So something complex. That was for HTTP. That's that one. As I said, you can have several other types of services, and one of the types of services you often have is service proxies. So here I have a small service proxy with this interface, compute, A, B. So I won't show you the implementation. You will have to discover, to do an educated guess of what it does. On the publisher side, so this is, yeah, let me see, yeah. So again, on the publisher side, you will create your discovery service. You get some, again, it's, I don't want to fix an address for this service, so I just generate an address on the event bus. I don't care. It's just to really illustrate that the consumer doesn't know anything except the metadata or a name. You register the service, and then you publish you create a record and publish it. Again, when you stop it, you unpublish it. I run that. Now, if I go back here, refresh, that's our second service. So this one was an HTTP service. This one is a service proxy. Here you see that we have a special metadata. It's because when we have created the record here, I set the class, the Java class, the Java interface. So it's added here, and we will see that it's useful to find the right service. And that's actually the address it has picked. Again, I just did a UUID, so it's obviously you won't use that. So if we go on the consumer side, here you create your discovery service again, and then you do event-based service get. You don't have to write a filter here because you can just pass the interface, and from the interface it will compute the filter to match this service interface as the name, and you will get the right one. And then it will call it. So you automatically get the service proxy here. So if I run that, if I pass 1 and 1, what will I get? Two. Yeah, okay. So the implementation is just doing an addition of the two numbers. Well, it's very simple, but it illustrates that it doesn't have to be REST. It can be event-based services or message sources and so on. That's good here, but so far, all the services I have implemented were developed with Vert.x. You probably have systems where some parts of it are not developed with Vert.x, and you want to import the services in the Vert.x discovery service. It what we will see in this demo. In this demo, we have this importer vertical. That starts the discovery, creates the discovery service here, but register a bridge. And a bridge is just some piece of code that is attached to the discovery service, and that will manage the bidirectional interaction between the Vert.x discovery mechanism and some other discovery mechanism. In this example, it's a static one where I know that I want to use the Star Wars REST API, SWAPI, and I want to import it because we don't know, maybe it will change, maybe I will switch to another service with more details or more Star Wars data or whatever. And it's what is done here. So inside a bridge, you just have a start and stop method. And in the start method, I just publish same API, some records. Here, that's the records that will represent the Star Wars or REST API. So it's a public REST API you can use for your demo and so on. It has very good availability, hopefully. So it will be available, and you can use it for your demo. If you use Docker, Kubernetes, and so on, all those mechanisms, all those container-based mechanisms are built-in discovery because I need to link containers together. We propose bridge for Kubernetes and Docker that will analyze the data, in Kubernetes, the services, in Docker, either the Docker API or the links, depends which one you use, and will automatically expose those services in the discovery service. So you will have access to those services. It's very important for HTTP service, as when you run in a container, you don't know your public port. You may find some way to know it using environment variable and so on, but generally you don't know them. So as you don't know them, you can't expose them yourself. So you will have to find some way to expose them, and it's what the bridge is doing. So if I start this, well, I'll go back here, refresh. Now I have my third service here, Star Wars, that is not implemented by Vert.x, but it's still exposed. And here on the consumer side, that's exactly the same thing. My filter will check for a service that is called Star Wars service, and will then get /API/people/4. And last time I checked, it was Darth Vader. Let's see if it's still the same. Yes, that's better. So, and a lot of different and other metadata about this character. So the purpose of this demo was to show you that you can import services that are not Vert.x based, so either using a bridge or using some code or other REST API that is exposed by the discovery service. Let's go back to some slides now. Don't worry, not much. 3 slides. So that was for the discovery. There's many other things that I didn't demonstrate about the discovery, and we're working on some extension to support consul, survey records, wait to build blue-green and AB deployments, and that should be part of 3.3.0. So the first version of this, of the toolbox. Now let's switch to a second topic, which is circuit breakers. Now, circuit breakers has been really popularized, well, at least it exists since a very long time. Again, I think it was not called this way, but something very similar to that. I found a reference in a paper from the 60s used in an operating system. Circuit breaker is just a pattern that avoids failure cascading. So when you have a node that fails, so to not propagate the failure to the user side, so to isolate it, and to react to those failures and to recover from those failures too. It's very useful when you have interdependencies between your microservices, and you have a microservice that is calling another microservice. And here, obviously, something may be wrong, so you can protect the call with a circuit breaker. The most famous circuit breaker today is Hystrix, and I will come back to that in 2 slides. So here, how it works. So you have the A, B, and C microservices. A, B have a circuit breaker, one calling B. A has a circuit breaker, one calling B. B has a circuit breaker, one calling C. When C crash or when the interaction fails, the circuit breaker intercepts the failures, and depending on its configuration, will either execute a fallback or report an error or do some more smart behavior. It's a circuit breaker is clearly a very simple state machine with 3 states. This picture is taken from a book, Release It, that details in detail the circuit breaker pattern. So when starting, a circuit breaker will be in the closed state. Okay. In the closed state, when there is a call, while it will execute it. If this call fails, it will keep a counter of the number of failures, and if it reaches threshold, it will switch to the open state. In the open state, all calls will execute a fallback. It will not even try to execute the actual service or the actual call. It will just execute some fallback. And after a timeout or attempt, some period of time, it will go automatically towards a half open state. This half open state, and it's where I don't really like the circuit breaker name, because in circuit breaker, you don't generally have a half open state, hopefully. It will let pass the next attempt. And if it goes fine, then it will say, okay, the service I was calling is back, so let's go back to the closed state. And if it fails, it will go back to the open state until the next period of time and switch back to the half open state. So with these 3 states, we have failure isolation. So we keep track, and if it fails, we have a fallback, so we don't propagate the failure. And we have failure recovery with the half open state. And because we have this fallback, we can smoothly react to errors. And we will see in the last demo that we can build a no downtime updates with circuit breaker. While not using Hystrix, so Hystrix, Netflix Hystrix is really great. It's much more than a pure circuit breaker. It has a lot of different fault tolerance patterns implemented. It's quite complex. The code actually is, well, they handle a lot more than pure circuit breaker, so that's why. You can use historics with Vert.x. There is nothing that prevents you to do that. You just need to be careful about a couple of things. It will use its own thread pools. So that means that fallbacks and replies from your service may be called in the wrong thread. So not a Vert.x thread, so you will have to handle the synchronization by yourself. It was made for synchronous and blocking code. So in Vert.x, most of the time we are doing asynchronous calls, so it doesn't really fit here. And it supports asynchronous, but it will require RX. Nothing against RX, but he will ask you to RXify all your APIs and so on. So sometimes you don't want to do that. If you're already using RX, no problem. But if you don't, then you will have to, you can't use asterisk, or at least not in an asynchronous way. And again, it will, all callbacks will be executed where, in a historic pool and not in the Vert.x thread. Let's have a demo of this. So I have this very simple service here. Again, I'm a big fan of the Hello service, so you are going to see a lot of Hello service today. So I'll start this one. Okay, so that one is on 8081. I will just check that it's there. Okay, it's there. And you have a consumer, and this consumer is going to use a circuit breaker. So first thing he has to do is to create a circuit breaker. You give it a name and some options. It's a data object, so you can configure it using JSON. Here is just to illustrate what you can configure. So the first thing you can decide whether or not you want to call the fallback as soon as you have a failure. Generally, it's recommended to call the fallback, as if you have a failure, you probably the operation has failed. Well, it's what it denotes. So you want to execute some fallback. Here is the number of failures before you switch to the open state. This is some timeout because sometimes a synchronous operation doesn't timeout. So that's the timeout after which we consider the call as a failure. This is a reset timeout, so it's the period of time before you switch to the half open state when you are in the open state. Don't worry, we will illustrate that with the small UI. So I just start some HTTP server here, and one under the request here, I will call the so this hello REST vertical, and to do that, I want to protect this call within my circuit breaker. So I do breaker.execute with fallback. Here, the first lambda expression you have here, take a future to say if it was a failure or not, and we'll execute some asynchronous code here. So I just do a get, and when I have the answer, I just say, okay, I was fine, no problem, it was not a failure. And this second lambda here is a fallback. So here I just display bonjour instead of hello. So if I start this, and I go on port 8082 this time, default hello. So what happens here is just say, okay, I got the request, I go there, I'm executing within the breaker context, but I'm still executing it. I do my get on my backend service, so port 8081, and I just display it back, so delegate the request, and everything is fine, so I just complete the feature, and the fallback is not executed. If I look at my circuit breaker UI, here, so we have the name of the circuit breaker here, its current state, it's not status, state, sorry, and the number of failure, 0. So let's now start the hello REST service. So we still have no failure because we have no call on it, but if I start calling it, you see, wait, so it will wait for 3 seconds and then execute the fallback. So bonjour, and if we look at here, in the circuit breaker, no, it's still closed because we only have 2 failures, and the next time, it will still try to access the backend service, wait 2 seconds, declare the timeout, so consider it as a failure, and execute the fallback. 1, 2, 3 again, and execute the fallback. And now here, so you may have slightly seen it was in the open state and then back to the half open state. So here, what happens now is that he has rejected, so it switched to the open state. Then after, I don't know, 1 second, it tries to go to the half open state. So next request will try to go through the service, and if it fails, it will go back there. So if we do that, open, up, and open again, and in the open state, it always executes the fallback immediately. And when we will be back to the half open state, no, it will let it pass the next request, failure again, open state again, and after a couple of seconds, half open again. If I restart my service, I will change something to say. If I restart my service and I'm in the half open state on the next request, it will try to call the actual service, backend service, and this time it should work, hopefully. So we should get hello here. And if it die again, 1, 2, 3, and so on. So that demonstrates the circuit breaker. Obviously, you can configure all the timeout and time and to meet your application. When you have chains of services, it's pretty important to use circuit breaker to each stage, or at least to isolate the failure. And yeah, well, that's more or less the basic feature about the circuit breaker. Here it's an execute with fallback. We have several, we have other methods, so execute, which has no fallback, so it will use the default fallback, or execute blocking for blocking code, and then it also catch exception and stuff like that. I will show you a last demo. This demo will combine discovery and a circuit breaker. I'm going to start 2 services, or some REST services. One that is called main, and the other one which is the backup. They are exposed the same service, the same interface, just fragile. So if I go here, there some REST service here and here. So one as a flag backup, or one as a flag main. And here I have some verticals that are consuming this vertical, this service. It do 2 lookup, one to get the main backend service, and one to get this backup is what is made here and here. And then it exposes some HTTP server too, and will let us, when we call this server, again, if we call the service with the circuit breaker. So if I call that, I might launch it first. So it's on the port 9000, right? Yeah. And now I go to the port 9000. You get hello. So main is replaying hello, while the backend is replaying bonjour. But what's interesting here, so here in terms of circuit breaker, we have a second one, some rest breaker, no failure so far. What starts to be interesting if I kill main because, well, I don't know, I want to do an update of main. What happens here at the next call, it calls the backup automatically because what happens here is that, well, I can't call main because it's not there anymore, so I call my fallback, and my fallback is to call this backup service. And if I restart main, let me change something so you see that there is actually a change. Automatically, so we'll go to the half open state at some point. Yes. And once we have reached the half open state, it will reduce the discovery of the service and we'll go back to the main service if it's available. So by combining discovery and circuit breaker, you can reach very easily no downtime when you are switching from a service to another one. So it's not completely the whole story of continuous delivery, but it gives you the runtime mechanism to have no downtime. This in combination of the of the instances of Vert.x and HA, you can really reach no downtime at all when you are deploying your new services and updating them. It can be used in combination or to these features and so on. That's more or less it about the demo. I still have a couple of slides. That's just the beginning of the Microservices Toolbox. What do we want next? More service type. I'm working on data sources, so JDBC, Redis, and Mongo. Bridge for Consul and DNS SRV records. So SRV is a type of DNS records. Adding weight in records to because it's basically a way to get load balancing, AB, blue-green. So to select to not always pick the same service, but when you have a list to iterate over using weight. Some API extension. Right now, the filters are JSON objects. We now support since 2 weeks functions in Vert.x. So actually, it will just be a match function that will take a record and will say yes, no, true, false. I would like to improve the dynamism support and some traceability to catch which services it's calling who and so on. I have all the data, it just needs to be exposed. Something that won't be part of 3.3.0, but part of probably 3.3.1 is to add health support for each service type as an option. So for example, if you have an HTTP endpoint and you have a health endpoint, so automatically call it and adjust the status of the service to out of service is not there. For bridges, for example, in Docker, you don't have this kind of things and so on, so it's really need to be optional. And for bridges, it might be a bit more complicated because you need to try this, but I have to see how easy it can be. Again, it's optional. We have seen a zero downtime update, but you can imagine extension to that. And we have actually a Google Summer of Code students that has started yesterday. That will help us to provide all the tools to build a continuous deployment pipeline, aggregated logging, and so on. And we have a combination of students that will provide some principle to build API gateways based on Vert.x and how to build such kind of gateway, or to handle A/B testing, blue-green deployments, and so on. So in combination of discovery, circuit breaker to really have a bulletproof system. Other concerns that should be addressed at some point: distributed tracing. So probably around Zipkin or something like that. So to know who is calling what and how much. And configuration management. This is something we don't address right now. configuration management will provide some configuration backend or storage, traceable. So you can imagine like a Git repository, something like that. And Node will get the configuration from this Git repository and will be able to apply the configuration dynamically, whatever it means, because maybe the application needs to restart, so it has to be to the application to decide what he has to do when he gets an update. That's all. We have a couple of minutes for questions. So unfortunately, I don't think I see the question again. I think we will have to reduce the same system we did last time, so with some Skype. There's really nothing I can do. Okay, do we have questions? Okay, so Julia told me that there is no question. Anyway, we run mostly out of time. So thank you for your attention. And well, if you have a question, feedback, or things you want to discuss, just send a mail on the Google group, and I will be happy to answer. And again, this is in progress work, so there is still many things to do. So if you want to contribute, it's definitely welcome. So see you soon, and have some good discussion on the Google group. And thank you for your attention. Bye.